So I got a number of these ESP8266 modules off of Kijiji, and I soldered on the headers. Some of them I did a better job than others. I'd say two of them I did really well, and one of them was not that great. This is actually the one that was not done great. I tend to use it for my experiments. So this is the graphic best matching what I got off the internet, this ESP8266, the WeMOS D1 Mini. And it's got, a sort of Wi-Fi capability, which I haven't really looked into. Also, it has a number of general purpose I/O pins, and according to the specifications, they operate at a 3.3 volt level, and also they have a maximum current draw of 15 milliamps. So, for example, if you would connect this one D3 here, or GPIO 0 directly to ground, it would have an unlimited current draw to the maximum of whatever is inside, and it would potentially destroy something inside this chip. So anytime that you use GPIO 0, you should have some sort of limiting resistor in there, keeping the current draw below 15 milliamps. So what happened is, when I got this infrared LED, I was trying to drive it at 50 milliamps, and it became immediately apparent that there is no way that you could run a 50 milliamp LED directly off a GPIO and a resistor onto ground. That wasn't going to happen. So what you have to do in this case, or what I did and I think you're supposed to do, is these are potentially the USB bus voltages here. And basically what you're doing is you're using a sort of a low power output to gate the main power that's going between the 5 volt USB to the ground. So what's happening here is you have that bus, the USB 5 volts going to ground, and it has a current limiting resistor like you always need to limit the amount of current going into a LED, but it also has the switching transistor. Also, an additional resistor is needed at the base to limit the current draw from the GPIO through the transistor, since the current is applied directly into the transistor and forms a pathway in the case of a bipolar junction transistor. So in my bag of parts, I had this cute little breadboard. I have like a larger breadboard, but this is the smallest breadboard I have, and it turned out to be just the right size. So what you can see there is that I guess you'd say columns, as per this graphic, the columns are all commonly connected. You see there's a slot in the middle going the opposite direction. So anything, the slot is dividing the upper and lower sets. So whenever you want like an IC, you want to put it across that slot. And then what happens is anything that's in a column that's on either side of that slot is a common connection. So that's great if you want to connect something, but it's an illegal move if you don't intend to connect anything. From my computer-controlled light strip project, I had a remote controller which no longer did anything because the controls were severed in that particular project. So I decided that I'd take the this IR LED out of that particular remote. I do have several of them that I class as probably redundant, but that's where I got that part from. I first tried plugging it just into a charger to make sure that it wasn't dangerous. It wasn't really clear at this point, but it was clear that the LED was on all the time, which was maybe a failure. But in retrospect, I wanted to tie it to the built-in LED so I could kind of see what it was doing, and that worked on my Arduino. But this could be the case of this sort of arrangement where the GPIO is put through a resistor and a light emitting diode to the 5 volt bus. So that means that it turns on in the case that the GPIO is in its low state, because it creates a reverse path in which the current flows not out of the IC but into the IC, or the MCU. So I suspected that's actually what happened there, and it was basically a reverse effect of anything that I was expecting. So at first I tried just a blink program to make sure that the LED was reliable for 0 and 1ing, and then I put my program in and changed the built-in LED for the GPIO 0, which is just code 0, so you just replace that string with 0, and compiled it, and it worked properly. And you can see what happens if you get in the way of the IR path there. So I can't see it because your foot's in the way. So my source there took a serial communications to send some bits in the NAC protocol, and it has to do with a constant sort of modulation of a signal with some blocks representing 0 and 1s. It turns out some cameras are sensitive to infrared light, so you can't see this with your eye, but an iPhone 5C in its front camera is recording this, and apparently it is recording that.